Hello and welcome. Today we will see the most important part in the industrial automation, PID controller, and how to use that PID controller in the TI portal. So PID controller is a proportional integral and derivative term which is used to reduce the error between set point and process value. Now let's begin. So in the TI portal, what we will do, we will add one FC first. And in this FC, from the instruction, from the technology part, we will call this PID. We will give the name for that instance, PID1. Instruction is called. Now remember, PID has time constant in its formula. So we have to call this PID block in a special block, and that is cyclic interrupt, which is continuously executing at 100 millisecond time. Okay, so what we will do, we will call this block in the cyclic interrupt. So now it is called in the cyclic interrupt. So what we will do, so now in the PID instruction, we can give set point, we can give process value, and here input underscore PER, that is directly peripheral input, that is unscaled input we can connect here, and the output for PID is calculated output, that is output peripheral, that is same as input peripheral, means the physical output that we can directly connect to the PQ address. The state of the PID, if any error is present at the PID, it will appear here, and the error bits. Okay, now what we will do, we will add one dB. So here we will give set point, process value, set point should be real, process value should be real, auto mode, and manual control value. So in the PID block, we will attach set point. Here we will use scaled process value. If we extend this, here we can attach manual value, the value for the PID output when PID is not in auto mode, that is manual CV, and here we can attach mode for the PID. So when the mode is 4, it is basically integer value. When the mode is 4, then it is in manual mode, and when the mode is 3, then the PID is in auto mode, and when mode is 0, then it is in inactive stage. So what we will do, we will attach mode. So always we have to write anything before PID, so that the execution of the PID it will be smooth. So when auto mode, we have to pass value 3 to mode, and when it is not in auto mode, we can pass 4 value into the PID mode. Okay. So here is acknowledge input as well and reset input as well. We can connect if it is required, means if any error is coming for the PID, then we can acknowledge that particular error from this place. So anyway, what we will do, it is not useful, but here we will attach reset and acknowledge. So data type should be bool. Acknowledge and reset. Now what we'll do, here we are using simulation and we will download this code into the PLC. So we will check whether any error is present or not. So no any error, and we will check this. So now PID is in manual mode. So if we make it in auto, the PID here, the mode is changed, but state is it is in 4. Now we will check. So if we click the configuration button here, we can do the basic configuration like controller type. So here it is in auto mode. So input, if we are using peripheral input, then we can select as a peripheral, or we can select normal scaled input. Output is also scaled. So here we can give process high limit, low limit, scaling high process value and the low, warning high limit, low limit. We can set out here PWM, what is the on time and off time for the PWM output. If we are using PWM output, then we can set the on time and off time here. Here output value high limit and low limit we can set it. Here we can set the output. When error is coming, substitute the output value while error is pending. So here we can set inactive current value or substitute the output value, which is the current value, to the output. And here the PID parameters. And here the most important, controller type. So controller type means when we are controlling forward action, then we can leave it as it is. Means when our process value increases, then output should increase. And when process value, while process value increasing, our output should, if we want our output should reduce, then we have to use the invert control logic. Here we will use forward action only. So after changing, we have to download it into the PLC. So here, when it is not in auto, it should be in manual. So here we will acknowledge first. So it is in manual mode. Now we will force the value and we will check. 50 it is coming at the output, and if we will change it to 80 it is coming to the output, and this thing is our unscaled output if we want to use. Now we will put it in auto mode, and if we output is increasing. So now what we will do, we will attach this instruction to the HMI. So we will use the HMI to test it. We will add one HMI device here. HMI, we will use 12-inch. So simply we have to select from this browse the required PLC. So it will automatically link the PLC and HMI. So no need to set the communication between PLC and HMI. Finish. Okay, so here we will take one bar. So here we will give set point tag. So like set point, we will give process value so that we can animate the set point and process value while tuning. Set point, this is process value, and one more we will add to see the controlled value, that is CV. So CV, we will select the PID output, which is real. SP PV and CV. So here we will give CV, sorry, SP, PV, and here we will monitor CV. PID output. Okay. So this is SP, PV and CV. Now what we will do, we will add three more tags which are most important in PID tuning, that is PID. So in the PID instruction, under retain, under control parameter, we can see this gain, gain means P value, I value and last D value. P, this guy is I and D. Now we will add auto and manual. Auto, so we will make that particular bit set bit, we have that auto bit. If that bit is on, our PID it is in auto mode, and here manual, so we have to reset it. So if that bit is 0, that means it is in manual mode. So also we will give some animation to the button so that we will be easily come to know that which mode it is currently. It is manual means for 0 it should be green, and for 1 auto mode button it should be green. Appearance, and to enter manual value also we will give one entry here for the to put manual value. If PID not, it is in auto mode, we can put manual value from this tag man CV. So the value is real. Okay, so now setup is ready to test. Okay, what we will do, we will add one trend as well, so that we can very easily see the set point and process value. Quickly we add it. So we will give set point, which is black, red one is, we will attach PV and also CV, also blue. We will add CV as well quickly. So the PID one output, yes, blue one is our output. Okay, so it will make very easy to understand. Now setup is ready. What we'll do, we will put it in simulation. So default value for PID is 120 and 0. So we will see the, we'll put it in run time. Okay, so okay, now what we'll do, we will put in manual mode and we will give 50%. Okay, 0%. Okay, 25%. So from the manual button, here we can enter the manual control value. Now if we put it in auto, so before putting in auto, we have to give some set point. Now let's say the range is from 0 to 100, we will give 80 and we'll put it in auto mode. So you can see slowly CV is increasing. Now if we start increasing process value, output should reduce. See, the rate of change in PV, it will be affected for the CV. So now 30, and if we put 80 here, and if we increase beyond 80, it should reduce. See, output starts reducing. So here you can see the graph as well. So set point is greater than PV. See, the 80 is our set point. I will reduce it so that we can. Okay, so set point is 75 and output is, our process value is greater than 75 and our output is reducing slowly. Here you can see 30, 29, 28. If we make it 65, output should start increasing gradually. So our, see, red line comes down, that is our set that is our process value. So our output is increasing now to reduce the error between set point and process value. If we make it 75, output should be stable. Okay, now output is stable. If we make it 100 PV, see output starts coming down, and if we make it 50, see the blue graph, again it will start increasing. Now this rate of change of output change we can control through P value, I value and D value. Now here P is, here what we will do, we will put 1 and we will increase I. So it should be very slow. See the rate of change here, and the moment we change I here, it is, you can very easily see here speed become, the rate of change of speed it reduced. So here what we will do, we will make it 100. If we will make it 1000, and we will see this rate again it reduced very much. Now if we want to understand this tuning, there is one more. Yeah, so for tuning we have to just remember this table. So if you see, the blue line is our output. See blue line is our process value, and this straight line it is our set point, that is reference. So there are 4 terms: rise time, overshoot, settling time and steady state error. So when we put the PID in auto mode, this process value start increasing. So rise time is the time from 0 when it crosses the set point. It is called rise time. Settling time is the moment we start the PID from that time, and when it get tuned, almost tuned to the set point, is called settling time. Overshoot means the amount it crossed set point, that called overshoot. And steady state error is the difference between set point and process value. So here when P increases, rise time decreases. When P value increases, rise time decreases. When P value increases, overshoot increases. This settling time, there is a small change in the settling time when we increase P, and steady state error decreases when we increase P. So when we increase I value, rise time, that means this time it get reduced. If this rise time reduced, then overshoot obviously it will be increasing. So here it is obviously increasing. Settling time increases. So we saw before, right? The moment we change the I value from 100 to 1000, the rate of change it reduced. So this settling time increases, and steady state error it will be reduced. So almost for all PID, P and I will be with the P and I only we can tune the PID. So for D, by if we increase the D, there will be a small change in the rise time, overshoot will be reduced, sampling time will be reduced, and steady state there will be a small change. So with the help of this table, we can tune the PID in the Siemens. So there is, so what we will do again, okay, so here okay, so now you see, to achieve the set point, it is still reducing because this I value is very high. So in this way, if you see, so due to this, if we reduce it again, it will be fast. And if we change the set point to 70, see, it is started little bit higher rate. So again we can put it in manual mode. So 25, again we can change the set point to the 10. Here we will put 70. So it started reducing. So in this way, we can use the PID in the TI portal. If we put it in manual mode, so now there is one more term. Now this PID is, the output of PID is bouncing. So the transition from the auto to manual, it should be very smooth. So quickly I will tell you how to do that. So when the PID goes in manual mode, that means negative pulse of auto we have to move PID output to the man CV, so the transition will be smooth. So the motor or control wall, so the transition for motor speed and control wall opening, it will be smooth, and it will not, there will not be jerk physically on the system. So now if we put here 80 and if we put it in auto mode, the same speed it will take. So now you can change it to desired speed. So now again it will start from 80, and again if we put it in manual mode, so here let's say earlier is 10, so it will not suddenly go to the 10. So in this way it will take this 72 and it will copy in the manual CV, and in this way the transition will be very smooth. If we put it in auto mode, again it will start from that earlier speed. So in this way we can add a lot of facility, we can add the hysteresis, if the set point is not achieved in particular 10 second, 30 second, then we can give alarm. So like this facility we can add. I hope you like the video. If you like the video, please like, share and subscribe. Thank you.